So this video is illustrating the layup technique for professional drone systems. This particular one happens to be made by a company that we actually built a system for, and then they never paid us. So I'm using it to describe some of the layup techniques without mentioning the company. It's a fairly common system, unusual in that it uses Kevlar as a top layer. The basic mold is laid out first with some mold release. You basically spray that on, and that's essential to have the epoxy release and not stick to the mold backing. On top of that, you then lay in a heavy, 2 or 3 layers of carbonara wax, or again, use mold release. Sometimes it's feasible to use both. The second you finish that up, then you begin to lay in a lot of epoxy. You can lay down fiber first, or you can lay down a thick layer of 30-minute or longer epoxy base. Generally, people prefer to lay down the carbon fiber, which is the black fiber. They cut it to a pattern first. Everything's all cut out and ready to go. And then they lay it in piece by piece. Either way, you're going to use a large brush full of epoxy to fill and saturate the carbon fiber. On top of that is a layer of light foam fabric. This basically gives it some stability without a lot of density. The carbon fiber is heavy, and then the foam makes it a little bit lighter. It gives it a layered stiffness. Again, that's laid on with epoxy layer after layer. And then unusually, on top of the foam has been a third layer added, and this is appears to be a Kevlar fabric. The yellow Kevlar fabric is quite common for strength. Interesting when you compare fiberglass, though, to carbon fiber and Kevlar. The fiberglass S grade or A grade actually ends up being stronger and more stable, higher strength ratio to bend ratio, more resilient. So most car manufacturers or drag racers, people that are building systems for weight and strength optimums, they're not using very much carbon fiber and not a lot of Kevlar except when it's needed. Kevlar having its high temperature characteristics, and carbon fiber having high impact capability. But the last layer basically again is laid on with another coating of thin epoxy. The whole thing is laid down in a mold. It's a 2-part mold. The bottom wing is laid in one mold. The top wing is laid another, and then the two systems are basically glued together. The third way would be to put a foam layer in the middle and then fabricate everything around the foam, but then you'd have to drill everything out. So this leaves it hollow and lightweight. The only problem is Kevlar is hard to cut. So once you're finished with the mold and it's cured over a 24-hour period, you got to release it. And essentially, the necessary element to do that is as you lay down your fabrics on top, you're going to have a release cloth layer, and then you're going to have a foaming layer that's underneath the release cloth, and that is a fiber, absorbent fiber, and that absorbs the extra epoxy. And after that, you vacuum bag it. Draw a high vacuum, and it squeezes all the foam together with the carbon fiber layers and the Kevlar layers under vacuum pressure, and all that extra material gets transferred to the release cloth and absorbed in the absorbent layer. All that excess epoxy is extra weight without any stability or strength.